My name is Fred, and in this video we'll look into exponential growth. We have a city, and it starts off with 2,804 inhabitants, and 5 years later we have 2,973 inhabitants. The x is the number of years, and y value is the number of inhabitants. So we can make 2 points, 0.2804, that is the first one, and the second one is 5,2973. I can't see those points, but I can right hand click on the y-axis and I can ask for show all objects. Here they are. Well, you won't be able to see them, but I can zoom in a little. And maybe I should, instead of that, move some of the axes here, reduce the y-axis, move around a little. It may take some time to find the way you want to show this. If you want to show the x-axis along with the points. Here they come. We assume that it is exponential growth. That is, that it rises with the same percentage every year. So I will now say fit, not foot, but fit growth. And I have a list of points, and as I've only got 2, it will fit very fine. Here I can see that in some way or another I start off with 2,804 inhabitants, and it is about 1% growth each year. If I want it with more decimal places, I can see that it is 1.18% rise every year. I have some more tasks, some more problems. If I could move this one. I can't, because it is fixed. So now I can move it. And I'll move it back. How many will there be after 8 years? Well, I have a spelling mistake. I can try to correct it. After 8 years, it means x equal 8. We'll do the same exercise as we've done before. And we'll find the intersection here. I don't think I got that right. Maybe there it is. If I'm not sure, I can do this, use this intersection, pointing the one line and the curve, and I get the point. And I can see that it is around 3,079 inhabitants after 8 years. When will there be 3,500? Well, that is y equal to 3,500. And again, I can intersect those two. Maybe I should just remove some of the things I don't use now. And then I will intersect that one with that one. And here I have my point E. I see the y value is as wanted, 3,500, and it takes about almost 19 years. The next thing I'll do, if I could get my arrow, is to make a different exponential function. So I'll remove that one, and I'll remove my x equal 8 and my y equals that one. I'll remove my points. Can do that by marking them and delete them. So now I have an exponential function with a starting value 200 and a growth of 13% each year. So I'll make my f of x equals to a starting value 200 times 1.13 to x. And here I've got it. So that is the formula for this function. Now I want to know how many years will it take to double the y value. You could make a formula for this and use it, but you can also try it out. So I'll try out with y equals to 500 and y equals to 1000. Now maybe I should do the normal exercise with changing some of the colors. So I have to find two intersections, this one and the next one. And then I could take the x values and make a difference between them. So double constant or time is equal to the x value of my point B minus the x value of my point A. So that's the doubling time. Of course, you should argue that it doesn't matter which of the two you use, but you could make a small example on that. So I'll maybe try to do that. Remove that one and that one and the two lines. So now I'll make two lines, and I maybe will use a slider. I'll have a slider here, C, and I'll start off with a lot less than this, maybe 100, and it goes up to 5000 or something like that. Apply. So here I have my slider. Then I'll do y equals to c. Here it is. I'll just make that a little bit higher. And I'll use y equals to 2c. There it is. I'll find the intersection points between that one and that one and that one and that one. Oh, I didn't. That one and this one. There it is. And then I'll make my doubling time as new double, and that is equal to the x value of D minus the x value of C. And now I could move everything here by moving my slider. And I see all the time the doubling time is exactly the same. It doesn't matter where the 2 points are, as long as the one is the double of the other with the y value. And this ends this video.